pain in the butt, but like we also had like 5 different telemetry systems, and so having a platform is really nice. Us at Microsoft are a platform company, so we can totally relate to that business strategy also. So I'm going to pull up this slide first. But hi, everybody. Wow, is there enough chairs for everybody? There's 4 seats here, so in case you don't have to stand. Was I in sitting mode or standing mode? Are we good? Can I don't know. I think I'm going to stand after seeing how many people are here. Anyway, so yeah. So thank you all for coming. David, did you want to talk about? Did you want to do your introduction yet, or do you just want me to go?
Just let it go.
Okay, cool. Well, So thank you to David. Maybe a little round of applause for having him bring me here and set this up on such short notice. So thank you. And check out Hack Collab, his startup, which is event like meetups, event space, and all that kind of stuff, and JS Camp. But yeah, so I wanted to. I had a couple things that I could talk about today, but I'm going to give you kind of a sneak peek of a segment of one of my workshops that I do. It's actually a 16-hour workshop, so I hope you brought your sleeping bags because we're not going to be here that long. But one of the pieces is about web performance, and I love sharing this at meetups and talking about web performance. One, because Webpack was solely made for web performance alone, and I'm a little biased, and it's near and dear to my heart. So yes, my name is Sean Larkin. I'm a program manager at Microsoft. I work on what's called the Developer Experience Group for Microsoft Edge. Specifically, my sub-team is called Ecosystem. So the thing that I'm responsible for doing is reaching out to frameworks, build tools, Webpack, Parcel, Rollup, all of these popular tooling maintainers, other JavaScript libraries that are prolific, and creating relationships with them. One of the things that we think is super awesome, you may have heard, we're building a new browser at Microsoft. And so one of the things that we wanted to start out and do right by developers is make sure that their voices are being heard. And what better way to do that is to start with all of the open source frameworks and tools that you use. And us at Microsoft are unique compared to a lot of other big companies is that we use the same technologies that you use every day, whether it be VS Code, TypeScript, React, Webpack, any name a JavaScript library that works with React, and I can probably confirm it for you, all those things. So if we're innovating for us, we innovate for you. So to have these relationships is really important. So that's what I do in the ecosystem team. That was really long-winded. So yes, I'm also a maintainer, and I fit kind of the dev advocate role also for Webpack. Who uses Webpack? Maybe a few people? Cool. Who uses a CLI tool that uses Webpack? Is there more hands? Yeah, there's the rest of the people. No, I'm just kidding. Who uses Make? Make? Okay. Yeah, there's my, yep. I feel you, man. We use Make at Microsoft too. CMake, actually. But anyways, so a little bit about myself, and then I'll jump forward to later in the slides here. But I'm a former tech support rep gone rogue. I got tired of not solving people's problems. You might have heard this spiel before if you heard a talk by me. But so I started learning JavaScript, I started learning Ruby, Objective-C, and then I finally fell in love when I found JavaScript. So you can also find me literally at all the places. It's at the Larkin, and it's just a play off of my last name to be funny, but most people don't get it. So I also have an AMA where you can try and ask me anything. It could be it doesn't have to be Webpack related, it could be life, I don't know, money, it doesn't matter. So now typically, if this was a workshop and we're going to be here for 16 hours, I have a whole segment of content that, I have expectations for you. But you don't get that. You're only going to get to talk about one of those things today, and that's going to be web performance. So with a show of hands, how many in their last sprint has had to focus on some sort of web performance feature? Okay, so that's a third of the room. How many in the last, 6 months has had to do web performance? How many how many people hate doing it because it usually requires you to dig yourself out of a hole of software engineering that you've done? That's me every time. We never focused, well, at my previous job, we never focused on web performance. We came back and we were like, how do we make this fast? And we said, we have to rewrite 9 months of work. So, but I'm glad to see no hands that came up for that. So when I talk about web performance today, I'm going to talk not about like, there's many different, like people can say perf matters and like all sorts of stuff, but like the specific web performance I'm going to talk about is page load time. So how long it takes for like me to like open my phone and go to dynatrace.com, right? And how long it takes for that page to be interactable with, right? So that's probably one of the most important statistics when it comes to your web application. And you may say, Sean, are you sure? Because features matter too, and I know they do. But just remember that that's the kind of web performance I'm going to be talking about. I'm not going to talk about like scroll jank or like, you know, how fast this paint is happening or how deep in the React stack are we going in render cycles. Like nobody, no, we're not going to talk about that kind of stuff. We're not building a multi-triangle that like needs 60 frames per second. Doesn't matter. So with that in mind, the top 3 causes of web performance problems are as seen here. So the number 1 is the amount of JavaScript that you ship on the initial download of your application. Did you know that JavaScript is the most expensive resource for the browser to process? It has to happen on the main thread for a variety of reasons. And it not only do you have to parse JavaScript, the engine has to evaluate the JavaScript, and then if the code's even used, then it gets executed, right? But as you're going to learn here pretty soon, not all JavaScript gets used on your web applications. So the next is the amount of CSS that is downloaded for the initial download. And it's not just the size, but the complexities of CSS are really interesting also. So it's not as expensive as JavaScript, but it can be just as expensive depending on the scale and how much CSS you're shipping. So what has to happen is that you have this, I wish I had the diagram. I'm going to steal it from one of our internal documentations on the Microsoft Edge page. But like it shows how essentially we have this layout engine and a formatting engine and a composition engine. And what you find out very quickly is that the more selectors that you have this like O of n complexity in calculating like which selectors respond to this piece of the layout. And so long story short, more CSS, the longer it takes for your page to render and initially load. And then finally, like a distant third. So like here's the top 2 and like this one is down here, is the amount of network requests that you know, are concurrent for the initial loading of your page. And like you'll be like, Sean, why did you use this kind of wordy explanations? Because they're very, like I'm very deliberate about what I've said here, right? Because it's the initial download, and you'll learn why. So here's some goals. I don't want you to like have a panic attack because some of these are really high goals. So there's things that I've talked about already, or that mentioned. So the first thing for JavaScript, you know, we strive to have 200 kilobytes of JavaScript uncompressed. So this is before you gzip it. This is before like, this is the amount of JavaScript on your initial download is pivotal to ensure that on the lowest priority device. So let's say like you're in India and you have a 2G network, that your product is going to be instantly accessible in 3 seconds. And that's the number that you're trying to reach. Now, you may not have clients who are in India and they might not need it. But you might work for a hospital and you might make hospital software and your doctor is basically has to choose between waiting an extra 2 seconds or treating a patient, right? And so I urge you to think critically about performance still mattering in a variety of scenarios. So it doesn't have to be like this. It could be 500 kilobytes. But the point is that it's a significantly low number, and I'll show you how we can accomplish it. And then also 100 kilobytes of CSS, uncompressed. I stress that really heavily, right? There's a lot of JavaScript libraries that are like, here's the new whatever, micro date functions library, only 1 KB. And then like, I reply in the tweet, is this the uncompressed size? No, Sean, it's actually 40 kilobytes. I'm like, come on. You have to know the uncompressed. And I'll tell you why is because compression is only a network feature. It only solves a faster delivery across the network because it's a smaller size. However, the browser still has to uncompress, parse, evaluate, and execute that JavaScript. So 1 megabyte of compressed JavaScript might actually cost 5 megabytes in its real actual cost. And then finally here we have HTTP. So for the network, it depends. So like if you're using H2, you can actually get anywhere from 20 to 50. I just say 20 to start with, and they're low benchmarks, and you can always, you don't have to get these numbers right away. This is something you can strive for. You can increment towards using your CI system. And then finally, this like my favorite number, and it's kind of blocked here by the camera, so maybe I'll there we go. You can kind of, I'll just say it. So 90% code coverage. So only about 10% of your code is unused when the page loads. So now you might say, like, Sean, how do I actually test this? So let's go to a page. Should we pick a page that I know, or should we? Should we do Dynatrace? Is it okay? Are you sure? Okay. Is the landing page like a WordPress site? Nah. Okay. Wait.
We're not that cheap.
No. Let's do Mutual of Omaha, a company I worked for already, just in case. Don't put them on the spot like that. I don't want to, okay. So this is the insurance company I used to work for. They sell mutual insurance and all this kind of stuff. Look, look, our network location services are working. Anyways, so to be able to understand your code coverage, what you have to do is open up Chrome Developer Tools. Now, in the future here, you'll actually be able to use this exact same tool in the Edge, the new Microsoft Edge Developer Tools. So something you can consider. Something to consider, okay. No pressure. Okay, so mine is open by default. So let's back up for a second. So I hope you can see this. Okay, you can. So the first thing that you're going to do is actually hit Command-Shift-P, or if you're on a Windows device, it's Control-Shift-P. You're going to see this drawer pop up, and you're going to type in coverage. So the first item that will show up here is show coverage, and just hit Enter or Return. So it opens up this empty panel, and what we're going to do is we're just going to hit the reload button, right? So what this tool does is it's going to instrument exactly what resources were needed to make this page renderable, right? So in this specific case, it's going to track JavaScript and CSS, and it's going to tell us all of those different assets that were needed and requested on the initial download and were necessary to render this experience that we just saw here, like this painting. So not any other pages, just this one specifically. And that's important, right? So if we look here, this is a tool I worked on, and the team, we did okay, not bad for an initial implementation. But one of the coolest things about this coverage tool is that it actually shows you the percentage of code that was actually used, right? So when I say code coverage, I'm talking about like this number down here, which says 500 kilobytes of 1.1 megabytes are not even used to display this page. But as I just talked about, code has to be parsed, evaluated, and executed. And so you just still paid 66% of the cost of loading this page for half of the code you don't even use. Why? Okay, so, well, why is a harder question, but I'll show you how you can fix this, right? So when I say code coverage, a good example, well, I was just at a company, Marfeel. Who knows Marfeel? Okay, so I was just over there with them, and they showed me we were doing some code coverages. They're at one of their internal pages was like 30%. I was like, that is great, right? Because only 30% of their code is not used. So try to strive for something around 30, 40. Start there, increment slower. But the point is, right, is that if these two resources are the most expensive processes, why are we shipping dead code that is equally expensive to process? So let's go back to the slides. Now that you know how to use this tool, you know how to analyze all these things. Probably most of this at a glance besides the network. So then we talk about, Sean, how do we solve this problem? Sean, I have 60% of my code is unused. How do I, what would be the solution? Does anybody have an idea? Just don't think about code splitting, but if we have 60% of the code that's not needed up front, we should take it out, right? Separate it to be loaded later at another time, right? So that's exactly what code splitting does. So I'm here to talk about how we solve this. And one of the coolest things is that, honestly, in my opinion, 80% of the websites that I see today, 80% of the websites that I triage at Microsoft internally, this is the #1 most impactful practice that you can apply towards web performance on your web application. Why? Because most people, the reason why their sites are slow is because they're shipping too much JavaScript, but really the reason why is because a majority of it is unused. So I tried to find a definition of what code splitting is, right? And then, so when I initially was working on these slides, I was like, okay, I can find some historical data. This must be a common computer science technique. Turns out it's not, because the first thing that shows up is the Webpack v1 docs on code splitting. So, however, who knows what this framework is? I know Dynatrace, every single Dynatrace person should raise their hand, right? Because they use Google Web Toolkit, right? Okay. So Google Web Toolkit had this sick idea and crazy thinking, let's make Java compile to JavaScript and then use it as a web framework. Like crazy. Who would do that? No, I'm just kidding. Sickos. No, but Google Web Toolkit is actually the pioneers of this technique. Now, would I use it today? No, but the technique is something that's super valuable and is the reason that Webpack exists. So, code splitting in GWT terms, they had this method which instructed to the GWT compiler that just says like gwt.run async. And so by implementing this, you could put functionality inside of this function call or whatever it's called in Java, and on this onClick event handler, you're actually executing this code inside. But when this is compiled, it actually takes this code here and compiles it into a separate JavaScript file that isn't needed up front, right? Because only if this click handler occurs do you need to fetch that extra JavaScript and then evaluate it and give the user the functionality. Do you guys use GWT run async? Have you used it? Not yet? There you go. Go try it out. I think it's still in the API.
We're actually more here to move everything.
That's true.
We're the Linux guys.
I don't endorse using GWT. No, I get it. So we got to talk. I might go to Linux. We'll see. Okay. So then comes that icon up top. That's so bad. Look at that. Anyways, but then comes Webpack. There's actually a really unique story about this, and I have to pull up the GitHub so that you can actually see with your true eyes the start of Webpack itself and how it actually came into fruition. I know from an unconfirmed location. Oh no, remind me later. Oh, that's fine. Okay. GitHub's just being safe. Okay, so if you go to the bottom of our Webpack README on our project, we have, like, ignoring all of our backers and sponsors, we have a specific location that's dedicated to all the people, oops, there we go, all of our sponsors and backers, a place that's dedicated to all the other projects that came before us that we thank, right? So James Burke of Require.js, Substack of Browserify, Defunct Zombie for the browser field spec, but most importantly, Google Web Toolkit, and then this project called Modules Webmake. So like, I'll be blown away if anybody even knows what this project is. Okay, so Webpack was born, and this is Sokra's words, because I wanted code splitting for Modules Webmake. Interestingly, the issue is still open. So the story is this. Tobias Koppers is a software engineer. At this time in 2012, he is working on his master's thesis, which was to make a web page. But he had experience with GWT, and he was like, I have this idea. Can we use this tool, Modules Webmake, but I want to implement code splitting. So keep in mind, this is a byproduct of his thesis, which is to make a web page. So he reaches out in 2012 and says, hey, I would like to add this feature called code splitting. I think it's really cool, and I think it would be a perfect fit for Modules Webmake. And Mediku, the original maintainer, was like, hey, you know, it's a missing feature, but I don't think we want to mess with this stuff, and kind of like beats around the bush, and then says, Sokra, I'm not sure. And, you know, basically Tobias is like, no, we can totally do this, I promise. And then he's like, here, I rewrote modules webmake in 2 days, and here's an example with code splitting. And Mediku's like, oh, thanks, but I don't think this is going to work. You know, we have other goals. I don't think this is going to work out too well. If you change the fork and change the name, and if you want to keep working on your other thing. And he's like, okay, thanks for the feedback. And then they talk about limitations, and he's like, okay, I hope it's okay. I moved it to Webpack/Webpack. And so that's 2012, Webpack's first commit had code splitting by default, right? So, and you'll learn here that this isn't using some plugin. This is a default feature in Webpack. Okay, and so obviously the issue, 2015, Dan Abramov showcased React Hot Loader and basically put Webpack more huge on the map. Pete Hunt at OSCON West also said, hey, Instagram uses this crazy tool by a German guy named Tobias, right? And also showcase it. And so you can see here in 2016 when Webpack got really popular, people were like, is there anything going to happen with this, right? People started looking at the bottom like, hey, is this a feature? And Mediku's like, no, next quarter, next year, right, 2016. So, or some people are like, that's how it started, right? So, I don't know, I think that's a special story and unique to us, and but we still give thanks to Mediku for being super cool and just, being like, yeah. I digress. Okay, so what is code splitting? So code splitting is the process of splitting pieces of your code base into, you can just say chunks, ignore the async. But the most important thing here is that it's at build time. So everything that Webpack does is static, right? So when you run Webpack, you get output in its bundles, right, of JavaScript that you can run for your web application. When you code split, you'll get more JavaScript bundles, which will contain the code that you want to load later. But you'll see very quickly here that Webpack will handle any of the asynchronous loading. So how does it work? Now, I usually give this crazy diagram, which I'm not going to, but instead, I can just tell you that when we make a dependency graph, we just give it a special color, a shade, and we say, well, okay, anything that's colored this way in the module graph, let's just put it into another file. You might say, Sean, why should I care? I just want to build some apps, man. Like, who cares about performance? Well, the future of the web is mobile, as you know. Who has to support a mobile or responsive page? Right, okay, so half of you. So mobile, a majority of the new traffic on the web today is mobile. And the point is that when you load less JavaScript, it gets interactive faster. But if that's not convincing enough to you, don't take my word for it. Take this study that says sites that loaded in 5 seconds versus the World Wide Web average currently, 19, have 60% more page views per visit, 35% less bounce rate, 70% longer sessions, 25% higher visibility, better indexing on SEO for both Bing and Google search, 2x greater mobile ad revenue. 77% of the mobile sites take longer than 10 seconds to load today on a 3G device. 19 seconds is the average load time for most of these networks. But did you know that if a page takes longer than 3 seconds to load, you lose half of your audience? So think about that. Food for thought, right? So let's talk about code splitting, right? We're going to solve this problem. So there's two types of code splitting in Webpack. And I'm going to, so there's kind of a syntax. So, okay, it's static and dynamic. And I use heavy quotes because it's not really dynamic. Nothing in Webpack is ever dynamic. We don't do anything dynamically. Everything is done at build time and you receive, but we can kind of fake it. And so we say dynamic. So, static code splitting. When would you use it? So, a good scenario is heavy JavaScript, right? So if you have a page, right, and let's say you need to do some 3JS visualizations. You're doing some 3D rendering and, on a canvas. Well, it's not needed until you get to until a user hits on a button, right? Well, don't import that stuff into your initial bundles. Lazy load it, right? Lazy load it until the user clicks on that button. So also anything temporal. So when I say temporal, I mean is it not visible now, but then becomes visible later, right? It still drives that message like it's the code or the functionality for it is not needed yet. So only when it becomes visible do you want to actually load this JavaScript or the functionality. And then finally, I mean, all of these things mean anything temporal, but like I want to give more like, I don't know, things that you can relate to in your everyday coding. So like routes. Who has a client-side router? Okay, yeah, so like all of your JavaScript routes should be lazy loaded, right? Because, I mean, a user is going to go to one, but the rest of them don't need to be loaded up front, right? Okay, so anything temporal doesn't exist yet and then does exist in the website. So I'm going to go over like I'm going to do a little live coding for you, and I hope you know it'll be understandable. Like I always like doing it after this kind of pseudo fake code. So here is an example of code splitting in the wild. Okay, so at the top we're statically importing a module called listeners, right? This is some event listener. Keep an open mind here. And then the next thing we're going to do is we have this variable called getModal, right? So it's pretty common. Somebody clicks on a button, loads a modal. So getModal is going to be our JavaScript module that has the functionality to like make it visible. And it has probably some more JavaScript related to it. Maybe it shows an image or does some other functionality, API calls, whatever. The point being is that this is equal to a function that returns a dynamic import. So who's seen the dynamic import syntax? Okay. Just want to make sure. For those who don't know, dynamic import syntax is a new syntax that's is now implemented in all browsers, I believe. Somebody can correct me if I'm wrong. But it's at stage 3. All browsers have implemented it. Outside of build tools, what it allows you to do is dynamically load a JavaScript module at runtime, right? But this was a unique opportunity for us with Webpack, right? Because we could say, hey, we know about your entire code base at build time. So we could take this and separate this JavaScript out. So there's a huge benefit to being able to have those JavaScript bundles that are separated before runtime, and I'll talk about it why later. But the point being is that this is browser valid syntax, and we wanted to align with that so that someday if you want to pop Webpack out, let's say your dev environment, whatever, it still works. It's browser valid. That's super important to us. So what's going on in this code base? So listener.on, and then it looks like we have an event called did something to warrant a modal being loaded. Keep an open mind. Okay, so what happens? Then we call this function, and behind the scenes what Webpack does is it converts a dynamic import to a promise. So you can really think about it as we have a function that returns a promise. So we've called the function, we unwrap the promise, and what the value inside of it is going to be the default export of that module. So we get our modal module, we're going to actually use it, we're going to say, get the modal and then init modal, some pseudocode. But the point here is that we waited to actually use this JavaScript module and call it for only inside this event. We didn't statically put it at the top of the file. So what happens, right? So what's going to happen here is that Webpack sees this special coloring for the dependency graph, right? We now have 3 modules in our graph, and one has this special shading for it. We know that it's an async import or a dynamic import, and so what Webpack does is it says, okay, separate this into a separate bundle. This one's going to be a main bundle, and these are just whatever names. It might be main.js, but the point is we create this additional file that doesn't get loaded up front. Okay, so I'm going to do a really super quick live kind of triage of a really small web application that's just JavaScript, no frameworks, so that you can understand maybe how you can go and take and identify something that should use code splitting that doesn't already today. So let's go to this beautiful web application. Look, I have a span. And okay, so let's just go through the code top to bottom, okay? So let's see. I'll hide this since we know we're building. Okay, cool. So we import some CSS. Don't worry about that. This is Webpack specific features. We have this function called make unique span. What does this do? Okay, so I dive into it. Looks like it uses low-es. But what it does is it creates an element called a span. whatever the span text is, it actually splits it into an array and uniques it. Oh, hold on, let me close this so I don't get any more spam from my coworkers who are just like waking up and wanting to do things. Okay, and then we just take and set the inner text. You know, vanilla DOM APIs, I know we're all great at them. And okay, so we use it here, we use it up front. And then we got some other stuff to contribute, like adding this div with a welcome, and we put an image inside of it, it looks like. Yeah, cool. And then we on this button, so when we click the button, it's going to add this text, right? So we uniqued the text. It takes away the unique, like, you know, it deduplicates any characters. Cool. Makes sense. So can we do better, right? Is there something that you notice that could be fixed? Feel free to shout it out. I don't mind. So say, yeah, well, yes, what function could be code split? That's right, make unique span, right? Because we don't actually use it up front. So like a great litmus test or a way to identify, can I code split this, is if I comment this out and reload the page, does it still render? Do I still get the same functionality? Do you need it up front? No. No. So let's go ahead and refactor this code so that we're actually code splitting it. We defer this function's use until the end. So the first thing I love to do, so one thing that I like for visibility as a developer is that I like refactoring code like in line where it was, right? So the first thing I'm going to do is I'm going to comment not only this out, right? That's the other test. Like, can I comment this out? Do I need it up front? No. So we commented this out. We know it still works. I'm in a dev server, so I can see my environment. If you don't believe me, let's just do something like this. Boom. Like, it's a live page. I'm not faking it, okay? Hey, you know what, developers, we only believe it if we see it, okay? So just to show you, it's a live dev server. It's real code. So what we want to do is first fix this static import. So the first thing I'm going to do, what I like to do naming pattern wise is I like to say like get something, like because it makes it kind of obvious it's maybe asynchronous. So get unique span is equal to a function, right, that returns a dynamic import, and it's going to be the same path to the same module, right? Okay, so there's the first step. Now if we looked inside of our build like feedback here, what you would have saw is that there's a new JavaScript bundle created automatically already. Even though I haven't even like fixed the functionality, Webpack knows immediately that when you use a dynamic import, it's going to say take that module, put it into a separate bundle, and don't load it up front, right? So now we actually need to use this function, but only when the user clicks on the button, right? So I'm a huge debug-driven developer, and so I always have to double check what the value of promises are. I can't like just I can't freeball that. So I'll do get make unique span, right? We're going to call our function. We know it returns a promise because I just taught you. And okay, so cool. We're here so far. I'm going to put a debugger in, right? Because that's debug-driven development. I'm just going to put like M because I know it's a module of some sort. Okay. So let's crack open the DevTools and we're going to learn this, like what do we get out of this when we actually use this functionality? Okay, so come on, where is it? Is that it? Let's try again. What do I need to click? Oh gosh, hey, thanks. Crowd-driven development. I'm like, why isn't this working? But indeed it's working, right? The way we want it to. Okay, so click. All right, I can feel my face getting red. That's so cute. I'm like, he's embarrassed. Okay, no, this happens all the time. I have no shame. Okay, so we had the debugger there. We stopped in the debugger statement. And so now we can actually identify, like, oh, so like great features of Chrome DevTools. Give that team a hand. We can see there's the module, and it has basically the value here. So like, if real debug-driven development is, we're going to console log the crap out of it until we know where the original function is, right? So I hit M, and there we go. There's a property called default, right? So I told you that Webpack will convert the module to always return the default export. So in this specific case, we know, well, there's our function, right? Span text, and it has all our code there. It's pulling the Lodash unique. Like I can even just say m.default. If you don't believe me, we're all skeptics, I know. There's the function, right? So in theory, we could basically reuse our commented out code right here, can't we? We could say const, like I don't want to rewrite this. Who does? So I can maybe just assign a new variable called makeUniqueSpan that's equal to m.default, right? The default export of the module, except use the right JavaScript. Okay, cool. So now in theory, right, I should be able to just drop this above, uncommented out, remove the debugger, reload the page, hashtag YOLO. Okay, is it going to work? You think it's going to work? There we go. Look. Okay, so we just code split this module, but if you don't believe me yet, we're going to, like, we got to make sure, right? You have to quadruple check because that's how we do it. We don't want to debug live in production, so what's the best way that we can find out? Okay, so here's all of our initial JavaScript resources, right? We have the main.js, which is our single bundle. So all of the code that has that is statically imported ends up here, needed for the initial render. And then, so I'm just going to clear out the traffic, right? And so technically, I should see something when I click, right? There we go. So here's the extra JavaScript bundles that have our functionality included. So I'll make it large so we can see. Now we wrap our code in source maps because it's our dev mode, but the point being is you can see the function, right? Span, inner text, unique span text, there it is. We didn't need that JavaScript up front, and so we just deferred it until we actually needed it. So yes, you just learned how to code split, and you just witnessed it live. So would you believe that that is code splitting? That is the full feature. That is how you accomplish it. Save questions to the end. We'll have lots of time for questions. I know that there will be many. So I want to now talk about a slightly different pattern that I think is really cool. Once I figure out how to get back to the page that I was on, which is the slides. There we go. Okay. So now there's dynamic. Now I won't live code this because it takes a little bit of time. You'll just have to believe these fake slides or these pseudocode examples. So to do dynamic code splitting, dynamic, because nothing in Webpack is truly dynamic, we are using the same pattern, right? So we have a function, or we have a variable that's assigned to a function. It takes a parameter, but it's that function returns a dynamic import. But this time we're doing something slightly different. So this time we actually have template strings and an expression in it. So we have a partial path, and then we're interpolating that parameter into the path, right? So, but what this enables us to do is we can now take and use, let's say, a runtime variable, like, I don't know, in this case we want to apply a theme. So window.feeling.stylish. Wouldn't that be cool if your API was that easy? And then we can call get theme and actually pass a string in, right? And module.apply theme, right? Like you'll apply the theme in the same way, else if feeling trendy, cool. That's super neat. And what this does is it lets you load bundles based on runtime conditions. And you might be like, what? This made 0 sense, Sean. What the heck is that? What, taco lady? I love that in my slides. So let's break it down because I had no idea what was going on here at first. So this is what I want you to focus on. The most important piece here is that we have a template string with a partial path, right? And then we have this variable. You might say, well, Sean, everything's static, so how is this possible? Well, we're passing Webpack enough information to be able to resolve something, right? We have told Webpack, well, there are modules here in this themes folder. So Webpack, you need to be clever and try and resolve any possible module that's inside of it. And we call the technical term is called a context module. You could blame Tobias for that. It might be easier if you thought about a directory module, right? So you imported, like, you are passing a directory that, you interpolate a module name, but you're going to get something in return. So I think the best way to describe this, though, so here's our folder layout. So I like just using stories where we tell Webpack to do things. So, hey Webpack, find me all modules in this possible, or find me all the possible modules in this partial path and resolve them. Make sure they exist and tell me all about them. And then create individual JavaScript bundles for each possible module. But do not put them in the initial bundle. So what this means, so now if we went back to the slide here, we would realize that when somebody calls get theme stylish, if stylish is inside of this is a module name, you'll actually load, 2.chunk.js, that lazy loaded bundle, right? So you get that automatically. So it feels dynamic, but as you realize, it's not really. It happens at build time. Don't forget that. So when do you use this? Now, honestly, you could use this anywhere, but I think I like to just use specific scenarios to kind of, enrich your mind in things that are possible, right? So you could go back and be like, oh, wow, we could do this today or tomorrow, or wait, yeah, we all work tomorrow. So A/B testing. Who has to do A/B testing, right? That's not fun. I hate it. I hate it. One, I hate it because I look at people's code and I see like JavaScript that's unused and I'm like, why is this here? They're like, well, these are, this is a test scenario for A/B testing. I'm like, well, why are you loading it if you don't need it? And they're like, I don't know, Sean. Well, look, you can use this for A/B testing, right? So super awesome. You could do thousands of permutations, generate 1,000 Webpack bundles, only load the test cases that you need up front based on the data that you get from like the window or from the user. Theming, super awesome for theming. You saw the code example, super relevant. And it's just convenience, right? Like I could use static imports for this entire process, like here. But what it looks like is like I'd have to define like 7 functions that import individual modules and then build a switch case. And it's like, well, if this, then do call that function. If not this, and then else if, or in a switch case. So like this is really convenient, right? Because you can just pass a string. So convenience is the last item. So I'd say exercise time, but really one of the things that, now I could talk about a whole bunch of other things like unique perf scenarios like, I don't know, I'll just go. H2, service workers, progressive web applications, performance ends, building for, all sorts of stuff. But I think really I wanted to just leave it on code splitting. One of the things that I haven't talked about yet that I will bring up is I'll answer a question up front first because I always get this question and everybody asks me. And then we'll talk about this. So somebody say like, Sean, but if you have a bunch of code splitting everywhere, doesn't that mean that you're putting the network, like a network delay in between user activity? Technically, yes, right? And so, however, the good news is that we have a solution for this. So you remember I talked about how statically getting these chunks at build time is really useful, right? So does anybody use service workers at work? Few people? Well, the service worker API basically allows you to use this feature called an asset cache or a service worker cache. So what you can do is with tools like the Workbox Webpack plugin, pre-cache files. Here, I'm just going to showcase this one because it's really svelte. It's nice. The point being is that you can use plugins in the Webpack ecosystem that'll generate a service worker for you, and it puts all of those lazy loaded bundles and resources in a service worker for you. So you don't have to like go all crazy offline PWA mode. You could just have a service worker that pre-caches all of those assets for you. So what happens is that when the user visits your page in a background thread, any of the lazy loaded bundles that you want to put in the cache will be requested in a background thread. So it doesn't mess with the render, like it doesn't affect the initial render of the page. But what happens is like, well now, let's say I go to the next route, instantly that file is already available. So there's no network cost. So using a service worker here is like this is the best use for a service worker in my opinion. Like if you use a service worker at all, do it for this, right? Because it's not only like useful for let's say single page applications, it's also great for like multi-page application architectures. You can take and literally like, here if I go to mutualofomaha.com, let's do this. We can do this and we inspect it and let's see, I think it's under application. Hey, there's our service worker. So if we actually looked at this, you can see this is what we did, right? A plugin, so this uses offline plugin. It's basically the functionality is identical to the Workbox plugin. You drop a plugin in your configuration, instantly creates a service worker and puts all of the lazy loaded resources in a network cache. Now you can have limits for things that you want to cache. So I think like for this one, we don't cache all of these up front, but the point being is that you can essentially download all of these extra resources in a background thread and you get like 50 gigs of like cache storage. Not to say that you should use 50 gigs of cache storage. I mean, most apps don't cost more than a couple like megs, right, or 10 megs, so you don't have to feel too guilty about caching everything. The point being here is that now the user never pays for a network cost once they've gone to the page once. So this is one of the best ways to employ, you know, like negating the network cost. So that question always gets brought up, like, so now you don't have to ask me. I mean, you can still ask me, it doesn't matter. I'll just say the exact same thing, but. I could also say link rel prefetch and preload, but it's not standard in all browsers, so, and it's not as useful as service worker cache, so just use a service worker. Okay, so finally, now this always stirs people up, so I don't want you to get a little worked up here. Okay, always focus on code splitting before you focus on caching. So, like, let me think of a scenario. Okay. Customer A, who heavily uses Webpack and is a close partner to us, comes to us and says, Sean, we really want to understand how bundle splitting works, or we want to create a vendor bundle with exactly this stuff in it, right? I said, okay, well, why are you reaching out because you're having web performance issues and load times? They're like, yes. I said, okay, could we load your page in production and see what's wrong? Okay, 55% of the code unused, 12 megs of JavaScript. So the problem is creating vendor bundles and focusing on network caching is only going to solve the network delivery, right? Only a couple browsers support bytecode caching, which allows you to negate maybe parse time. So I always tell people, always focus on code splitting first, right? Because you're always going to get huge benefits. I wish I can't share our internal case yet, but look towards the Microsoft Edge blogs because I'm about to publish an internal a team internally that we did what's called a performance club. And so I work with this team and we do like this long document and we talk about like how we identified areas of opportunity to solve. And like this one was like 18 megs of JavaScript to 2, right? And we cut load times in half, which was super impactful. So look for that. Okay, so the next question, which is, Sean, how in JavaScript frameworks am I going to actually do this, do code splitting, right? So I know I'm like answering questions before they get asked, but I should just add these slides. So who uses React? Okay, cool. So we'll start there. So React.lazy. As of the latest stable React version, you have the ability now to almost have first-class code splitting. It's like 1.5 in my opinion, and I'll show you why. And then you can feel free to disagree or be upset about it, but that's not my problem. No. Okay, so we worked really hard to encourage the React team to do this, and we were super happy that they decided to. One, because it reflects a common problem. No, I don't want. Where is it? This is not the one I want. React.lazy. Here we go. Okay. So, who uses like the latest React? Like all of you probably, because, okay, cool. So, now, so this used to actually be really complex to lazy load in a React application because you had to set a bunch of different things and like different events and all sorts of stuff. So instead of just statically importing a component, if you have one that's temporal, you can use react.lazy. So I think the lazy function just lives here. I'll find it. It lives just like, usually it's import react, comma, and then like component, lazy, suspense. So you can take and swap that out for an identifier that equals react.lazy, which takes a function that returns a dynamic import, right? So similar API to what you saw in vanilla JavaScript land. And then you use suspense to handle like fallback for like, if it takes a long time to load and there is a network cost, it'll show a spinner component or something like that. So, but the point being is that now, with not too much extra effort, you have code splitting here for this component. Now, I might encourage them in the docs to maybe include an example where it is temporal, like based on some state, then you return this component. But the point is still the same, right? So anytime that you use a static import, you would change it to be this instead. And then based on some sort of state or event or a route, you then choose to return this component. So who here uses Vue.js? Sorry, okay. Yeah! Well, guess what? You get a way easier time. So I'm just going to pull up a Vue.js project. Sorry to all the React fans here. No, it's okay. I'm biased. I really love Vue, if you don't realize this already. Where is it? I have it somewhere. Where did it go? I thought I had it here. Well, I'll just show the docs. So, well, no, because it's actually more impactful to just show you. I'll use this trip report project. So I'm doing this like side project at work because, you know, when I travel places, it would be nice for me to have an easy app instead of writing out a giant document to talk about what I talked about. So I was trying to make an app that does it. Okay, so as you can see, I've already spoiled it. But the beautiful thing, so if you don't know about Vue.js, long story short here is that they use this single file component system because they built on Webpack as a platform to create developer and user experience features, and which is great. And so instead of like JSX, they have a templating syntax that compiles to the same thing that JSX does. So it's unidirectional data flow and all that stuff, no two-way binding. But they use kind of like things that were really popular in AngularJS, like directives and like, you know, stuff like that. So the point being is that if I want to use a custom component in another custom component, there's a registration system that can be statically analyzed. So down here, I have to import this trip form for it to show up, right? And I register it in this property called components. Okay, so long story short is that their API, they built it in a way that says anywhere that takes a component instance, so like just statically importing, it also takes a function, make it large here, a function that returns a dynamic import of the same component. So I've literally had to do nothing but make a one-line change. First class code splitting versus 1.5 class code splitting, in my opinion. Okay, so, and this is actually like when we were at Mutual of Omaha, we were doing like a big framework assessment because we're an enterprise company and Java architects, you know how they get, they're like, assessment for everything. No offense, you guys are Java, well, yeah. You get it. You're like, yeah, that's right. So essentially, we determined that like this specific exact feature, maybe because I'm also on the Webpack team, was the most impactful for us because we knew that even if we gave like a designer some project, they built a bunch of components and just statically imported them anywhere, we had the satisfaction of knowing we could go in and make one-line changes to make huge performance impacts 6 months down the road. So to us, we saw this huge return on investment. So that's enough me standing in my soapbox for Vue.js. Okay, now finally, Angular. So Angular does not specifically have a unique API for code splitting at the component level. However, Todd Motto has this great article, Angular code splitting. Okay, here it is. So Angular has a little bit more verbosity into how it's defined, but you can kind of trick component code splitting by using this load children feature in a route. But if you are using Angular, what's cool is that I guess you don't have to use the dynamic import everywhere. Maybe not my ideal API, but that's just my opinion. However, basically you just pass the path to the module and then the name of the export that you want to lazy load. In this case, the routes. So if you don't already, if you've not read this before, it's called Learn. Well, I mean, it's kind of a Todd motto like selling his courses, but really this article is just, it'll get you 90% of the way there. So take a look at that. Todd's a good friend of mine. I love Todd a lot. Okay, so I think I've gotten ahead of all the other questions I can think of. So at the end of the day, like these are the top things that you can focus on when it comes to web performance. Always try and focus on these things first, right? Now, at the end of the day, you should just measure, right? So use a performance tool, measure how long it takes to become interactive. But like most of the time, I don't even do that up front. Like I go to a project, I just look at these numbers, like check the coverage. Okay, it's a huge amount unused. Code split it all, and then like huge wins. So ideally, I'd love to see we get to a place in the world where we actually have to focus on more specific kind of performance concerns, like image loading and maybe even vendor caching. But right now, in the kind of place in the web, this is the most impactful thing that you can do, you know, not to be too hand-wavy. So, yes, thank you. Okay. I should sit down now so I can answer questions. Okay.
Oh, we got many shitters. So
Nice! Initial questions is good.
I'm just on the front row.
Hello.
Hey, thanks for coming.
Of course. Thank you for having me.
Talking about code splitting,
Mhm.
of course. We're seeing some project that I was working on. We're using Webpack chunk name.
Yes.
The thing over there that you put inside.
Magic comment.
The
I'll pull it
magic
up.
comment.
Yep.
So how does that magic comment mess up my code splitting if I'm like maybe loading like one type of component in different places, and well, one type of component that has like 5 different components, I'm just using one. Does that mean that I'm loading like that chunk like with all of that just for that specific component that I'm loading the first time, or?
Okay, so I'll repeat the question so the people on the live stream can hear. So I'm just going to summarize it, and then you can be like, Sean, that's not even what I said. You want to basically, you're asking what are the implications of using Webpack chunk name API or like the magic comments when you're code splitting? Does it have an effect on it?
On code coverage, actually. That's
And code coverage as well. So, okay. The Webpack chunk name feature, really all it is kind of a developer experience feature that just gives it a name for a lazy loaded bundle. However, there is a scenario where if you give a bunch of bundles the same Webpack chunk name, which is not recommended for code splitting, then it merges them into a single chunk. So, number one, don't do it. So don't name multiple lazy loaded bundles the same name, right? Because then it merges them together. Ideally, you want them separate. And then 2, use the Webpack chunk name magic comment. So the feature here, it gives me a good segue, right? Because I can kind of talk about it briefly in my workshop. I kind of go way in depth on all the magic comments. But you can go to webpack.js.org, and like my favorite part is that this is searchable, right? Like, okay, magic comments. We go to our docs page, boom. Okay, so I get excited about how cool that is. Because it like, find things in the doc and it's useful. Not everybody has those experience with docs. So Webpack chunk name, basically it's an inline comment that you can allow your bundle to be named. There's a long-winded history to why it is the way it is. You could probably find it in a GitHub issue. Long story short, in Webpack 5, we're going to minimize the need for this because we're going to have named bundles in your development mode by default. So this should be an easier experience, and you may not even need to use it anymore. But for those who, let's say, like a good example, the Microsoft Outlook so what do we call it? Outlook Web App, OWA, is one of the largest single-page applications. They generate 400 lazy loaded bundles, right? And we're talking across 20,000 modules. Probably one of our most premier React applications that really focuses on performance. And so they use this significantly because they want to understand how to debug. By default, Webpack just gives numbers to these bundles instead of names. And so this is a nice developer experience feature that you can leverage yourself. So answer your question, hopefully?
Yes.
Awesome.
So in the React example,
Yep.
you showed fallback spinner,
Yes.
but not in the view example. I wonder if
Yes. Well, actually, so I leave it out because I don't know. Well, yes. So Vue does support it. So instead, so there's kind of like a shorthand, and then there's a more a heavier API that lets you have all these features. So I'll show you if you go to the Vue.js.org website and you search Vue async component factory or async component. Let's see. Okay, actually, here it is. Beautiful. Thank you. Thank you, Docs team. They're so good. Okay, as of Vue, what is it, 2.3? Evan also saw this feature show up prior to when React Loadable and a bunch of other libraries started adding these features. So this is possible in the same way. So instead of assigning it to just a function that returns a dynamic import, you can have it be equal to a function that returns a object in this case, and then has a component property which takes a dynamic import. And then you can also pass a loading component, an error component, even a delay for, like, if it loads faster than 200 seconds, don't show the loader, right? Or if it takes, and time it out after 3 seconds, right? Like, so it's really rich and configurable. So like, that's all possible. We found in Mutual, like, we didn't need to use this as much. Maybe there are just a few cases and scenarios, but yes, it is there and it is available if you need to use it. Any other questions? Oh yeah, I owe you a question. I owe you a question. Unless I answered it?
No,
Okay, okay. You're next.
How does code splitting work with vendor space? So imagine you have a son and uses some 3D stuff.
Yep. So vendor splitting is what I was talking about. Like, so I cringe at at our docs because we have we have like code splitting, and then we say vendor splitting and bundle splitting. The only code splitting that creates asynchronous bundles is code splitting. Anything else is like a cacheability feature. So like what you refer to as vendor splitting is like using the Commons chunk plugin or split chunks. And 98% of the time, I endorse people to not touch it. So like, don't mess with it whatsoever. First, fix unused code. And then if it's like, well, we could do more by removing duplicate code across, like, let's say, multiple entry points, go ahead and use the feature. But 90% of the time, we found it does more harm. Like, that's why we removed it from a common plugin to like this kind of embedded API in Webpack 4, because we saw people kept using it, but creating these giant vendor bundles unknowingly what the consequences would be. So not to say like don't use it. We do a lot of this stuff by default. And you can find it in our documentation under split chunks, I believe. So I think maybe it's the split chunks plugin. Do we talk about it? Yeah, so like, disclaimer, none of you use this until you until you implement code splitting first. Promise. I promise please listen to me. I don't even like showing it, but it's okay. So there's this plugin, and it's an API that helps you handle like multi-page app architectures. But like, I have found in 90% of the cases that just code splitting and not even worrying about this and letting Webpack do the defaults is more performant, like in most cases. But we do have some scenarios where we handle, like, split chunks is turned on for lazy loading, like for asynchronous bundles, but like, it's only like really, there's very specific scenarios where I've really found it useful, and in most of them, it's not. So I know it doesn't directly answer your question, but I'd say focus on code splitting first.
Actually, it's just a silly detail question. When you did the example with the click,
Yes.
and you just took out one module.
Mm-hmm.
When you showed the network, it loaded 2 bundles.
So that's actually the advanced code splitting feature that Webpack does behind the scenes that does vendor caching. So it's a vendor caching feature for lazy loaded bundles. But you're absolutely right. The only reason why is because I'm also importing Lodash, a Lodash library. And so we have this special algorithm. If I didn't use unique from Lodash, it would just create 1 bundle.
Nice.
But you can actually read about, let me see, optimization split chunks. So it actually kind of showcases, we have like a reading guide that talks about this. Where is it? Yeah. So here's the examples. So the default is only for lazy loaded bundles, and we just basically say, does the lazy loaded bundle contain modules from no module? Is like that no module bigger than 30K? Are the number of parallel requests, greater than a certain amount? And it doesn't affect the initial, request, right? So like, then we choose to create a async vendor bundle. But that's okay, right? Because it doesn't affect the initial load time. So we kind of have this freedom to do that, knowing that it's a good practice, right? But don't touch it by default. I'm sorry, I don't mean to gatekeep this feature, but I just see in 90% of the time, it does more harm than good. So, but great observation actually, because like I was nervous. I was like, oh, they're probably gonna say something about 2 bundles, but it's true. If I didn't use unique Lodash, like I can do it if you don't believe me, but yeah. So Yes. Any other questions? There are still a bunch of hands, I think.
Also, please remember we have questions coming from our.
Oh yeah, yeah.
who are
Here, you
watching
can drive this. I'm sorry.
We have Luis Lasauce, who ships this question. Could Webpack also help embed initial required JavaScript inside the HTML to optimize the initial page load? For instance, to pre-render entry pages with sources embedded. As an example, small images as base64 are also JS code for CSS.
Okay, so is that's not specific to lazy loading? It doesn't sound like.
I would say
Right. So what was his name again?
Luis
Or her?
Lasauce.
Or Julius?
Luis.
Oh, okay.
Luis.
Whoever you are, person. I'm not gonna butcher names.
Human.
Human, person, developer. There are, yes, more techniques that you can take advantage of for optimizing your web application. You're absolutely right that there are many others. What I have found in my experience and in a lot of real-world applications is that this is probably the most high impact and return on investment performance feature that you can implement in your application today. And almost, actually, like I have statistics that say, like, out of all top 1,000 Alexa or 10,000 Alexa websites, the average amount of unused code is like 55%. So, like, we can make the web like that much faster. So there's lots of other techniques, but this one's just specific to like the issue with unused code and you know, kind of shows why code splitting is even an important feature today.
We have another question over there, and then another question from
Okay.
our audience online. Who raised their hand? Yeah.
Code splitting with Redux. I had to do it before, and it's not fun.
Yeah.
I just want to verify. If I'm using a docs pattern, right, and there are certain releases that, okay.
No, it's actually great. Like, it's a great question.
If I'm actually using the docs pattern, there should be an easier way than what I have to do. So,
I agree with you.
um,
So the question is like, what is the suggested advice for code splitting when you're using central state, like a central state management library? Because it's not just Redux. MobX has the same issue. Flux has the same issue. Okay, so one of the caveats is that you basically have central state that's like, you try and have to have statically available for all of your code, right? So like, that's one caveat, right? I can tell you what newer frameworks do today, and I think that Mark, I'm forgetting his last name, he's the maintainer of Redux, but I believe there might be documentation or there might be features in the works on how they're going to try and accomplish this, because it is a prolific issue. So the answer, at least I can tell you, so I'll show you how one framework does it, and I think that it should be possible, or it may be possible today, but I just don't know how to do it myself with Redux. So in Vue, we have a very similar library called Vuex. Vuex async, Vue register module. Yeah, okay. So Vuex has this way of taking and dynamically, or to lazy load pieces of your store, right? So this would be the applicable case, right? So essentially, anywhere that we have a method called register module, I say we, but I'm not even on the team. I'm on the fan team. Anyways,